So we're gonna do 6.3 Taylor and Maclaurin series. So we had a series, the form of series last time, C7 and equal to 0 to infinity. And we have x minus a to the n power, right? So if x equal to 0, we have x to the n power. If x equal to centered, we call it like that, right? Centered at x equal to 0, then we have a c to the n power, not n power, c sub n, x to the n power, right? And centered at x equal to a, we had this form, right? The last time. This is a series. Now, from this series, we have Taylor series. So Taylor series, the form of a series like this, okay? So we have the summation n equal to 0 to infinity. Then we have the function notation, but then this will be derivative, okay? So, they said here. Can you see that here? So f has a derivative, yeah. So this means how much derivative? Well, the first prime, second prime, third prime, fourth prime, and so on, right? Okay, then they have a similar with this one, right? And then they have m factorial in the denominator. So we have the first term has f of a. They said that f at a, right? And first term, which is the first prime, and x minus a, and then we input the number of a, right? So, and so on, second prime, third prime, fourth prime, until nth derivative, right? We could, this is a Taylor series, and if, like this one, if we have a, right? And if we have a equal to 0, then this is a Maclaurin series. Okay, so let me do this one. Let us do this. We denote a polynomial. So Taylor polynomial. So if we say the polynomial P naught, then first term, which is f of a, right? If we have the polynomial like this, then I'm following this one. Second one, f of a, and then second one is second term, which is f prime of a, x minus a, right? Now, the third one, f of a plus f of first prime of a, x minus a, and plus f second prime of a, x minus a to the second power, right? And second power, we have to have 2 factorial, which is 2, right? Now, piece of 3, polynomial, then the first term, second term, third term, 3, one, two, three, right? Over 3 factorial x minus a to the third power, okay? That's how we denote like a polynomial when a equal to 0. Then, look, we have a definition about the polynomials, how to express. Look, I brought this one here, definition. Nth derivative Okay, Taylor polynomial. Then P sub n. Okay, so it's like what we wrote down earlier, f of a. This is come from the Taylor series, right? So f prime of a, x minus a. If x equal to 0, then we get the only x itself. And we get the third and fourth, fifth until n. Okay, so if we have when x equal to 0, that's a Maclaurin polynomial, same as the series. Okay, so let me write down. Just highlighting. If it is 0, then it's a Maclaurin polynomial. Okay, it's about to see. X equal to 3. Means x equal to 3 means equal to 0. Okay, so let us do example. Find Taylor polynomials. Find the Taylor polynomials. P naught, P sub 1, P sub 2, and P sub 3 for the function ln x and x equal to 1. So in this case, a equal to 1, right? Look, how do we do? So we're gonna just do like earlier, like this. Okay. P naught. All right, so in this case, x equal to a means a equal to 1, right? So f of a. So what do you get this one? F of 1. Means that ln 1, right? What do you get this one?
Oh.
0, okay. All right. Now, P sub 1, which is f of a, plus second term, which is f prime of a, right? So that is f of a, which is f of 1, plus f prime of 1. Okay, now, what's f prime?
One over x.
Very good. Then what do you get?
1.
It's 1. Good. So we get 1. All right. Now, second polynomial, which is the first one, and f prime of a plus f second prime of a, right? Okay. Then, oops, I totally forgot. Look. Then we have to have x minus a, right? X minus a. So we're gonna have x minus a. X minus A. So we're gonna make X minus A, which is X minus 1. It's 1. Why I have it 0? Okay, let me denote this way. Sorry about the message. So it's 0 plus, it's 1 and X minus A, right? Okay, so this will be X minus A. Ah, crazy. X minus 1. Yeah, once I make a mistake, and the brain cannot working properly. Okay, so X minus 1. Okay, so second one, we're gonna have okay, forgive me for taking time. X minus A and plus F second prime over A, X minus A over 2 factorial, right? Okay, now F over A, which is F over 1 plus F prime over 1, X minus 1 plus F second prime over 1, X minus 1 divided by 2, right? Okay, so what's the F second prime?
1. Probably.
Second prime first, then I say what you meant.
Negative 1.
Negative what?
1.
1 over x squared, right? So it will be negative 1, right?
Yes.
Okay. Okay, so we will have f over 1. Let me see. We get the first term is 0. Second term, we get x minus 1 earlier. And third term, f second prime of 1, which is negative 1, right? And x minus 1 over 2. So we will have x minus 1 minus and
Plus,
x.
okay.
Did I make a mistake?
No.
No? Okay. How about, let me see. So minus, right? And then
S
x
over.
minus 1 over 2, right? Correct? Okay.
Yes.
Now piece of 3. Okay. Let us do everything is correct. Let me just rewrite this one. Copy in here, paste. Okay, now we're gonna make this one actually 2 factorial, and then third one has 3 prime and 1 x minus 1 over 3 factorial. Okay. All right. Then this is the same thing. And hold on 1 second. I need your help. do you have? So this is the second power when we have second derivative and factorial over 2, right? So I'm missing 2 there. So please pay attention. And I have to make a third power, right? So I think I made a mistake here. Oh, I did not make a mistake here. So cube, second, right? And derivatives, second derivative, third derivative, all right? Okay, let's move on. Oof.
Ooh.
Okay, so this is the second power. I omit out. And look, third derivative. What again? Negative. Just quickly. Negative x to the second, negative x to negative 2 power. Derivative, what do you get?
-2 over S3 power.
So 1 over x to the third power?
-2.
But then there's another negative, so it's a positive, right? Yeah. Correct? So negative 3,
Oh,
right?
yes.
Correct, okay. So then we get the 3, we substitute 1, we get 2 over 1, so which is 2.
2.
Yes. X to the third power is 2. Okay, now, so we have a positive, and third one, we get the 2 there, and x minus 1 to the third power over 3 factorial. 3 factorial, which is
6.
6. And we get 3, right? Okay, then we're done. X minus 1, because the first term is 0, and minus x minus 1 to the second power over 2, plus x minus 1 to the third power over 3. This is a polynomial first 3 terms about the Taylor polynomial. Okay, we found here. Okay, then let me show you the graph, how it looks like. I believe this one. So why we are doing this one? Because we want to approximate. Do you remember what we did in the calculus 1, linear approximation? And there is a tangent, same as a tangent approximation. And after that, linear approximation, after that, we have what is called the differentials, right? Okay, and then your professor mentioned that, oh, if you take the calculus 2, there is a power series and Taylor series, we're gonna approximate to better, right? Okay, so this one is that, because linear approximation, we have to make only the linear, right? When we approximate to the graph, but then Taylor series, when n is getting bigger, we're gonna better approximation nearby the number, which is given point, which is a. All right. Okay. So this is a linear, right? When x minus 1, right? So looks like this one. And then looks like this polynomial piece of 2, right? And then this is the original function ln x. Okay, what was it? When x equal to 1, they want to approximate nearby 1, okay? and p sub 1. The first of all, the first term was the 0. Okay, 0. And then p sub 1, which is linear there. And then p sub 2, which is the parabola, open, looks like open downwards, right? Because negative, okay? And then p sub 3, there is another polynomial, okay? Then the highest degree is the cube, so we have like a x cube curve, looks like that, yeah. So p sub 4, whatever curve they give us, so this n increases, we get the better. Let me write down what we are doing. We are doing p sub n. So this n is increasing. Let me write down as in. As n increases, the graph of p sub n becomes a better and better approximation of the graph. Maybe I want to squeeze in a little bit. Of the graph of f of x equal to ln x, right? The near x equal to 1. Okay, so do you understand what we are doing, right? Okay. Let us do Maclaurin. Finding, find formulas for the Maclaurin polynomials. P naught, P sub 1, P sub 2, and P sub 3. Find a formula for the nth root, not root, heavy rate, nth the root is the heavy, nth Maclaurin polynomial, and write it using sigma. Notation. Okay, so we have the function f of x equal to e to the x. What are the nice function, right? So we do derivative, everything is the same. They say that using the Maclaurin polynomial, right? Means that when x equal to 0, right? X equal to 0, just x equal to 0. Okay, then look. We know everything derivative is e to the x, so we get p naught, which is f of a, right? Which is 0, right? Which is e to the 0. What do you get?
1.
1. Good. We get 0 plus f prime of 0 x. Because normally we have that, right? X minus a, but then x equal to 0, right? I mean, a equal to 0. How about that? So this will be x, right? Equal to 0. Okay, then what do you get? We get 1 plus f prime, which is e to the x power, also 1, right? So we get x, correct? Please correct me if I make a mistake. Then we have f of 0 plus f prime of 0, x. Now, second prime, f second prime of 0, x minus a to the second power over 2 factorial, but x second power over 2 factorial, right? All right. Now we have 1 plus x. Now we can think about this. F second prime, which is e to the x power, e to the 0 power, which is 1. We just write down this one, right? X squared over 2. If you want, you can write down factorial, that's fine. And piece of 3. We want to find until piece of it, right? So we have that. Third prime. Okay. Once again, this mean is equal to 0, right? I'm sorry, this is equal to 1. Let me write down. Yeah, because e to the x power, the derivative e to the x power, right? E to the 0, which is 1. And then also, this term has only this one, right? So we will write down plus x to the 3 over 3 factorial, okay? So this one, we do more and more, okay? This form will be d2, I want to make a d2, plus derivative of n, and at 0, and x to the n power over n factorial, okay? So this is how we write down series, right? So series, okay, hold on 1 second. This will be nicely, one more time. This one, 1 plus x squared over 2 factorial plus x to the third factorial over 3 factorial plus x to the fourth factorial. Okay, plus x to the n factorial over n factorial. Okay, how do you want to write down? Series, summation. K start k equal to 0 to n. Then x to the k over n k factorial. Is okay?
Looks good.
Looks good?
Yes.
Okay. And then hold on 1 second. I'm gonna bring the, I don't have to bring the graph. Huh? Let me just do this one. Screen. Only this one, I think. Yes. This one is that. Okay, this is when x equal to 0, right? So when x equal to 0, we get approximate linear, and then looks like a parabola. And third one is like a cube, right? And P naught is the constant, which is 1 in this case. Okay, so constant x squared, x to the third power, and so on. All right. Okay. If they ask you about the coefficient, right? So coefficient will be, in this case, we can say the coefficient, the first coefficient, right? C naught and C sub 1 coefficient, and 1/2 is the C sub 2, right? Coefficient 1/3 factorial, which is 1/6, right? Okay, this is a coefficient. Make sense? Okay. All right. Then one more I want to talk. If maybe after this, maybe we do the more function, then I will come back to this function and talk about more. Okay, so let us do this one. Second one, we have sin x. All right. So we want to find the formula for the series. Okay. The Maclaurin series at this point. So here. Second one, g of x. Let me write down just f. Sin x. So at x equal to 0, which is a, okay? All right. So f prime of x, what do you get?
Cosine S.
Cosine x. We do 0. So cosine 0, what do you get?
1.
Very good. Second prime, what do you get?
Negative sin S.
Very good. We get
Yellow.
0 good. Third prime.
Negative cosine S.
Thank you. Negative cosine 0.
Negative 1.
Negative 1. Good. And then 4. After 4, we don't do anymore, right? Otherwise, we get confused, right? So we're going to note as number 4. So first derivative of x. So negative cosine x, we do derivative. What do you get? Sine x. Very good. And then we plug in 0. What do you get?
Yellow.
We get, hold on 1 second, sine 0. This is 0. Okay, good. Now, P naught. Which is f of a, f of a, f of 0, f of 0. Oh, we did not find f of 0. Sine 0, which is 0. Yeah. So 0. P sub 1, we have 0 plus, look, we're gonna have f of prime of 0, x, right? Then f of prime of 0, it's 1 there. Here is 1, right? And we get just x. How about P sub 2? We get 0 plus x plus f second prime of 0 x squared over 2 factorial, right? Then f second prime of 1, which is 0. This is 0. Yeah, whole thing is 0. P sub 3, 0 plus x plus 0 plus, okay, so third prime. So what do you get this one? Third prime. This one we get -1 because over here, right? Okay, then -1, then we can say the negative x to the third power 3 factorial, right?
Why not the P2 not equal to S? The P.
Oh, did I? Oh, yeah, sorry about that. The third term is 0, right? So, okay, let me clarify. Third term, this one is 0. So third term, whole thing is 0, but we have x there, right? Thank you for pointing out. Okay. Okay, then we get this one 0 plus x plus 0. Okay, how about x minus x to the third over 3 factorial? Okay. Okay, piece of 4. Let's just stop here. We get 0 plus x plus 0 plus and negative x to the third power over 3 factorial. Now we're going to do fourth derivative of 0, x to the fourth power over 4 factorial, right? Okay. What do you get this one? Let me see, fourth power. Oh, we get 0 again because of this. Yeah, so we have 0. Okay, then since it's 0, let us find out one more. Yeah. Okay, piece of 5. We get 0 plus x plus. How about start here? Why are we doing this? Whoa. So start this one, right? Well, I was crazy. Why are we doing that? Copy. Start here. And okay, never mind. Let me write down x minus x to the third power over 3 factorial. Now we're going to write down the fifth of 0, fifth derivative of 0, x to the fifth over 5 factorial. Okay. Now we don't have that, but we can create. We do derivative sine x. What do you get?
Cosine S.
Cosine x. Now we do fifth derivative of 0, which is cosine 0, which is
1.
1. Thank you. So it's 1. All right, then we get this one will be x minus x to the third power over 3 factorial plus x to the fifth power over 5 factorial. Okay, now how can we create the formula for this? So this one will be, look, the sign changed, right? So let me write the -1 to the n power x to the 2n plus 1 over 2n plus 1. This time is a factorial, right? We had the experience last time. Without factorial, we express as 2n plus 1, remember? And other power increased by 2, right? So 2n plus 1, right? Well, it wasn't have a factorial at the time. But today we're going to have a factorial because they have a factorial, okay? All right. Now we can create this one. The series is summation k equal to 0 to n power, then the sign alternatively change. So -1 to the k power x to the 2k plus 1 over 2k plus 1 to the factorial, not to the factorial, 2k plus 1 factorial, all right? Is it good? So we derive the formula for the sine power series, right? So basically this is we called Maclaurin series polynomial. Yes. Okay, now cosine. So we started doing the Maclaurin, the series, the polynomials when x equal to 0, right? So f prime of x, what do you get?
equal to sine s.
And prime of 0, which is negative sine 0, what do you get?
Yellow.
0. Second prime, what do you get?
Negative cosine s.
Second prime of 0, negative cosine 0, what do you have?
Negative 1.
Negative 1, very good. Okay, so third prime,
Sine s.
sine x, very good. We have a third prime of 0, sine 0, which is
Yellow.
0, good. Okay, fourth power, derivative of sine x, what do you get?
Cosine s.
Sine x with the derivative of 0 cosine 0, which is
1.
1. Very good. Okay, then let's see. P naught, which is f of a, which is f of 0, which is, we did not find f of 0 again. So f of 0, which is cosine 0, which is
1.
1, good. So we will have a 1 in this case. P1, f of 0 plus f prime of 0 and x, right? So f prime of 0, we get 0. Yeah. Here, okay, this one. All right, then we get 1 plus 0. It's 1. Okay, right? Okay. Polynomial second one, f of 0. And we get, how about start this, yeah? We start 1 plus the second one. And x to the second power over 2 factorial, okay? So f prime, second prime of 0. We have negative 1 there. Yeah, this one. So this will be negative 1. Then we get negative x squared over 2 factorial. Okay, piece of 3, which is 1 minus x squared over 2 factorial and plus third prime of 0, x to the 3 over 3 factorial, right? F 3 factor, I'm sorry, so third derivative, this one, right? We get 0. All right, so this will be 0. The whole thing is 0, so we have only that. Piece of 4, which is 1 minus x to the second power over 2 factorial. Now we do fourth derivative of 0, x to the fourth power over 4 factorial. Okay, fourth derivative of 0, we have 1 there, right? So we write down 1. Okay, so this will be look, 1 minus x squared over 2 factorial plus 1 x to the 4th power 4 factorial. Now, how can you express as a series this one? Okay, let me write down then. Sign alternatively change, and x to the 2m, the even power over even, so 2m, and there's a factorial sign, right? So this will be k equal to 0 to m, and x to the 2k over 2k factorial, all right? But we know that cosine is even function, sine is odd function, right? So they apply here as well, right? Can you see that? 2, 4, and then earlier sine was a 3, 5, okay? All right, now. I want to go back to this one. They say that example. The Taylor series for f of x equal to e to the x. I cannot read my handwriting. Oh, I don't think this one. Oh, this one. Let me see. Let me see. Sorry about that. We have the example, find the sum of the series looks like that. This series looks like e to the x power, right? So let me bring here e to the x power. Where it go, right? So this one, very similar. Okay, so we have note. Why I cannot make copy? What was this? So e to the x power, which is a series. K equal to 0 to infinity, x to the k power over k factorial, right? Okay, look, n factorial same as k factorial. Now the x represent 4 to the n minus 2. So let's see, this will be, we rewrite equal to n equal to 0 to infinity. Look, negative 1 to the n power, 4 to the n, and 4 to the negative 2. Yeah. And all over n factorial. Okay. Since this is a number, we can take out from the series, right? There's no n, right? So this will be 4 to the negative 2 and 0 to infinity, we have a negative 1 to the n power, 4 to the n power over n factorial. Okay, now, what we are doing? So, same n power, so we can combine. So we can say that 4 to the negative 2 series from n equal to 0 to infinity, negative 4 to the n power over n factorial, right? Okay, then can you see that x to the k start to 0 to infinity? So negative 4 to the n, similar format, right? So we can say that this will be 4 to the negative 2. The series will be, and then we're gonna say that 4 to the, hold on 1 second. Say it one more time. Look, e to the x. X is corresponding here. Yes? Okay. So we're gonna have e to the x. How about this? 4 to the negative 2. This will be e to the x. But x, this one replaced by x, right? This is x. Okay, x to the n power, right? Okay, then this will be e to the negative 4. Okay. So this is, you can write down this one as it is, or you can make a simplify with a negative power. It's okay. So this will be 1 over 4 squared e to the 4th power. So e to the 4th power 16 or 16. You can say that too. 16 e to the 4th power. All right. Thank you for coming.